Hi, everyone. Welcome to recording. Eric's not here yet, so we'll just start with the meeting. But we have Leah Follett back from as a HGAPS alumni. And do you want to introduce a little bit about yourself, or Psych 525 alumni, I should say? But would you like to introduce yourself?
Hi, I'm Leah. I was in Psych 525. I have a master's. I love R. Most of my research has been an assessment of anxiety, but I want to go into suicide assessment. So yeah, it's me.
But yeah, oh, Eric's here, so he can start leading the meeting now. Thank God.
Everyone, everyone who was in 525 this semester, Chase, Wilson, Grace, this is that Leah Follett.
Yeah,
we looked at your poster and your code a lot.
I was just giving my props and giving my roses while they're still fresh before you arrive. But yeah, it's amazing. Very exciting.
Nice.
yeah, we were just doing quick introductions, and Leah
Excellent.
introduced herself to the group. So yeah, you can take it away from here.
Oh, well then I should stop eating. Awesome seeing so many people here. I'm coming straight from the Brumley Trail. I had a really nice ride. I used 2 shortcuts to make sure that I could get back within minutes of on time, and got to do all of my favorite parts. And I set a personal speed record because I was hauling the mail to make sure that I could get here. I was excited about you guys, and I didn't wipe out. I did lose control once, but all good. All right, so did you already go over the plan, the agenda plan?
No, I just want to start off with introductions.
All right, so we're going to do 5 minutes of introductions and updates. Did we already hear about Wilson getting a job?
Yeah.
Are you still, where are you now? Are you in Tennessee, North Carolina, New York?
I'm in Knoxville right now, but I will be in a better place, that being New York, tomorrow. Well, actually, technically North Bergen, New Jersey. But I will, be looking for places as soon as I get there. But yeah, the job will officially start on the 26th. But I'm just trying to get as far ahead as possible before then, so I can get back to this, my real job.
Hugely excited for you. That's awesome.
Thank you.
Rachel, I haven't written back to your friend, the stats major. It occurred to me while I was on the trail and not able to pull out my phone that I would love to have her come. She is welcome to come next week. Loop her in, please.
Okay. Jesse's a dude. Jesse's a dude, just so you're not surprised when you see him.
I heard not surprised, but I didn't hear the middle part of the phrase.
Is my mic working?
No, it is. My ears aren't working.
Oh, he's a dude, so you're not surprised. And
oh,
yeah, it's a dude.
Okay, awesome. Cool.
So I talked to him today about it, and he is also in Dr. Hess's lab at NC State, I believe, and he's working on research and publications with them. So that's really in his field of study, which is statistics and social psychology. So for this project, he said that he's really interested because of the analyses that we want to run, and he would be like really glad to consult on the statistics, but he's not sure how much he can contribute, both because of time and because he doesn't know much about like psychology things. He's very much just a stats person. Yeah, I was talking to him about SEM modeling and ESEM modeling, and how they relate to factor analyses, and then also a little bit about measurement invariance. And he was telling me, like, I know how to do all those. I know how to calculate all those. I don't know how those are applied to psychology, and I'm not sure like how you would use those results to make informed decisions about psychological measures. So it's kind of flipped. Like we would know how to do the latter. He knows how to do the former.
Yeah. Well, let's see where it goes. This is why we have ARFs. So
I showed him the ARF and everything. He said he's totally fine if he doesn't get an authorship, but he would definitely want to like consult and stuff because he's interested to see what we're gonna find.
Fantastic. On the right, I also realized that I owe you a response to your Eggers test.
Right.
It'll probably come from O'Hara tomorrow during the layover, but I'll get back. I'll type it on the plane. Okay, so our plan for any other spectacular updates? All right, the tentative plan. Is down here, number 9, plan for tonight. Do quick introductions and updates. Do a review of the measures section, the method section and measures, the tables from the HCL of the 4 groups. The HCL, when we went over the pregame, had the most examples, most material for us to look at. So we're going to go over that, see everything that the HCL group pulled together, and start to do a show and tell of how we would pick and choose and create a super version, which we're calling the Mons model. So everybody drafted stuff, look at it together, decide which parts are the stuff that you actually want to use in the version to advance to the next round. We also have some didactics talking about building on what you know so far and taking it the next step as an introduction to confirmatory factor analysis models. And then we want a big chunk of time to be in the breakout rooms to talk about what we have so far. And based on what we just saw going through the HCL stuff, what do we want to do next, and how do we want to work on stuff over the coming week? And then report out, hear what each group is going to be doing over the next week, make sure that we have a master plan, and end as close to 8 o'clock as we can. As at this exact moment, I'm still wearing my biking gear. My bike is still in the car, and I have to pack still to leave for the airport at 4 a.m. tomorrow. Plus take the bike out to put everybody's stuff in the car. So you can feel safe that I am not going to just want to hang out and have long meandering conversations into the wee hours. My wife she's like, never happens. They won't even know what you're talking about. Rachel?
So before we start, I had a quick question about the data set for the HCL, and also I don't know if this applies to other groups. Are we allowed to clean it up in a sense? Like, because I've found a lot of interesting results in the data set, in that some people reported that their age was 4 years old or 0 years old. And we had one guy take 700,000 seconds to complete the survey. And it's kind of I don't know how much it's throwing off, but it's making the graphs look really weird.
Yeah.
I also noticed the minimum age was 0, and I was like, that can't be right. I don't think that a baby can fill out one of these surveys. So I have the same concern, so I'm excited to hear.
There was someone that reported that they were in a manic episode for 95% of the year.
I'm proud of you guys. I noticed the same thing when I was cleaning the data to make sure that we weren't going to do the deductive identification thing. And I left that in as an Easter egg for you guys to see whether you would, I'm being serious, to see whether you would pick up on it or not, and whether you would be okay passing it forward or not. Before I would let you send something for publication, I would be like, is there anything that you think might not pass the scratch and sniff? And so you guys, so that, yes, we want to clean that. Now, the part which is interesting is that we've got 3 data sets that are going to have very similar issues. And Seifa talked with me earlier this week about exactly the same thing with the PHQ-9. So what would be interesting, not tonight, but July, is having a discussion about that and coming up with a consistent policy for things that we're saying are supposed to be adult report. Do we cut at 18, or do we cut at 21, or for the ones that have impossible values like that, do we only get rid of the suspicious score, or do we throw out the entire row of data? Those are pretty different things. And so there's a lot to unpack there, but the short answer is yes. And same as we are looking at each other's method sections and critically evaluating them and deciding what do we want to put forward. Part of that that's outstanding learning. On Bloom's taxonomy, you're doing critical thinking, and you're learning what you would want to do next. So you're leveling up super duper fast. But imagine us having a written 2 ways of this being awesome. Imagine us having a written description of here's how we did this, here's exactly how we scrubbed it or cleaned it, that was posted on like a Wikiversity page somewhere. And whenever you guys were writing up a poster or a paper or something like that, you would know exactly where to go to get the exact description and the R code to do the scrubbing. And whoever sets up the scrubber, put a DOI on it, or put a CC0 or a CC by 4.0 and get thanked for the scrubbing. So there are a whole bunch of ways that this is going to connect together to be really, really excellent. Plus, what we're actually doing is building the system that would be the basis for everything in the assessment center. So this isn't and we'll use it 3 times. We'll use it about 70 this year when we get it really tuned.
Cool. Sounds fun.
Yeah.
Ideas.
So I did an impulse buy this morning as I was doing an errand. I was stuck at the UPS store and they had some really funny cards, and I bought a card. I'll run down and get the card. I bought a card because I was thinking about you guys and things that you've done that made me smile, and remember the jar of awesome in the lab. So I've got a card for you guys that I'll hold up to the camera, but I left it downstairs. So all right, do you want to do the HCL review first, or do you want to do the CFA thing first? I think let's do the CFA thing first, and I'm going to set a timer. My proposal will be do that first, then do the HCL thing, because when you get into the breakout rooms, you're probably going to do stuff more directly related to that. So have that be fresh in your memory, have recency work in for you as you get into the breakout rooms. Sound good? Welcome, Alexis. Phone is freaking out. Colin, set a timer for 25 minutes.
Will do.
Awesome. Okay, what you guys know so far is everybody walked into this with an understanding of basic correlation. You've learned about reliability and Cronbach's alpha, which is a very widely used but not perfect measure of reliability. And you've learned exploratory factor analysis. What I hope you've taken away from the exploratory factor analysis is the idea of when you have a lot of items, the correlation matrix, you could report the whole correlation matrix, but that's a lot of numbers. And at some point, people are like, there are two reasons to summarize that. One is TMI, it's too much information to take in. And the other is the reliability idea is kind of a unifying theme of what people actually want to do is rather than looking at a person's score on every single item on the HCL, they're like, can we just like bottom line it? Could we add it all up? And is that giving us an accurate measure of what's going on? So you give a scale, the simplest thing to do would be add it all up. And whoop, there it is. There's the bottom line. There's your total score. That would be great if it worked, but sometimes it doesn't. Sometimes the items go in opposite directions. Then adding it up is really stupid. Sometimes the same scale measures more than one thing. That's exactly the issue. If you looked at oh yeah, another quick update. The paper that I sent you guys last week, I'm like, this is confidential, it's under review. It got submitted on Monday. Lillian and Dwani actually watched me fight with the portal to get it submitted to a top journal, and it got rejected today, right around lunchtime. So we're revising it to, they didn't actually give us any feedback. They're like, this looks great, but not for us. Send it somewhere else. Good luck and Godspeed. So we're on to the next journal. But that paper, if you actually read it, it is looking at the industry standard outcome measure for psychosis. How bad is your psychosis? Does this drug help your psychosis? The entire field has been adding it up, like to get a total score. Here are 30 items, add it up. That is your total burden of psychosis. Does this drug reduce your psychosis? Awkwardly, those 30 items aren't measuring one thing. They're measuring 5 things. That isn't what the authors, the people that wrote the items, they thought they were measuring maybe 3 things, but no, it's 5. And those 5 things aren't correlated with each other. So the secret mission that team of investigators is doing with me is seeing if we actually broke it into separate pieces, would we see on a pure measure of delusions or cognitive impairment with psychosis that's not diluted by all this other stuff that is not the same thing and not correlated with it, would we have an easier time finding good treatments for psychosis? Probably. Alpha assumes all the things that you're giving me are just measuring one thing, right? Because I'm going to bottom line how reliable this is if I'm only measuring one thing. But what you guys already know with all the data sets that you're working with is you're not just measuring one thing, with the possible exception of the PHQ-9, where it was designed to measure one thing, but then SAFA found that other technically skilled people are like, this actually may be measuring 2 things. Exploratory factor analysis is a way of taking all the correlations and trying to summarize it into how many major things are we talking about. Confirmatory factor analysis is kicking it up a notch and saying, I'm sure how many things, I'm measuring. I'm ready to make predictions about the data before I look at the data. And so you're actually writing out, and what you guys will learn is you're working with the R code, is when we start using Lavon is the package that we'll use, or you could do a little bit of this in Psych. What you're actually doing is writing out the formula. So you're saying, hey, Lavon, I think that the HCl has 3 factors on it. I'm telling you ahead of time. And the first factor, and you get to pick what you name it. You could call it F1 for factor 1. That's the least amount of typing. Or you could call it Sunny. Sunny gets major loadings from these items. And then the second factor, you could call it F2, or you could call it B, or you could call it dark. And you're like, dark, factor number 2, gets major loadings from these items. And then number 3, I don't know what we want to call number 3, C or F3 or Pluto or substance misuse, or the and the HCl group is in a much better position. You guys have been talking with each other. What would we call it? And you would write out factor 3 has major loadings from these items. So this is very different from what you've done so far, which is like, we've got 32 items. Tell us how many major things there are underneath. And one of the pieces of the output that it gives you is, if you only keep 3 major dimensions, here's the percentage of variance of all 32 items that you're explaining with that. So it's telling you, here's how much of everything going on in all 32 items and all the different ways that they're connected does 3. That's a huge simplification, but it's also telling alpha, hey, alpha, you're wrong. It's not 1. Don't just look at a total score. Still with me? So am I sharing screens? Excellent. So we've got the exploratory and confirmatory factor analysis. So you're looking at slides right now. And it's still slide 1. All right. So confirmatory factor analysis is actually going to test how accurate is your model, how accurate is that ballsy prediction that I can explain pretty much everything that matters about what's going on with 32 items, just using 3 factors and calling the shots ahead of time, saying these belong to Sunny, these belong to dark, these belong to Pluto. So it'll give you tests of fit. And I'll with how many minutes we got left?
16.
I'll show you where some of the output is. I won't explain how all of it is constructed yet, but I'll be like, so when you run it, here is the test of how accurate is that model. This is different than anything that you guys have seen before. What you're used to when you look at a p-value is you are rooting for it to be significant. You know already that significant results are easier to publish. And if you're doing an honors thesis or a master's thesis, you're supposed to write down a hypothesis. You're supposed to write down an aim, and you spend months working on this project, and you're cherishing your aim, your hypothesis, and you really, 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 really want it to be right. And so you're rooting for the p-value to be significant. This flips that on its head. When we're in confirmatory factor analysis land, it's testing how bad is your model. They call it a goodness of fit statistic, but they didn't ask me what would be an easier name to teach people. They call it a goodness of fit, but it's a test of, are there significant errors in your prediction? Are there significant mistakes in your prediction? So you don't want this to be significant. And it's going to be significant for all of ours, for everything. I'm telling you that ahead of time. I've looked at a lot of these. There is no chance with the sample sizes that we've got that they're not going to be significant. So one thing that we'll be able to theoretically test is, do we have the right number of factors? The second thing we'll be able to test is, do these items load on the factors that we expected? The part which is weird is the riskier prediction is actually saying this item loads on sunny. It'll test that and it'll show us how strong the loading is on sunny, but that's not the risky part. The risky part is saying that same item, it's only about sunny. It loads not at all on dark. It has no connection to dark and it has no connection to Pluto. When you guys looked at the factor loadings 2 weeks ago, we talked about the rule of thumb was like higher than the 0.35, 0.33, 0.4, bigger than that, that's a good loading. But if it's doing that on more than one place, oh snap, that's a cross loading. It's loading on more than one factor. And then we talked about rotation and we talked about Promax and these other things. And what rotation is trying to do is make the big loadings bigger and the small loadings smaller to get to simple structure. With CFA, with this confirmatory approach, this is the really gutsy part. It's saying this item goes to sunny and tell me how much it loads on sunny. I'll let the data tell me exactly how strong the loading is, but my prediction, my theory is that the loading of the same item on dark is 0, exactly 0. You guys already know from running your exploratory stuff, it's not exactly 0. You could go back and look at your output and look at all of the loadings to 3 decimal places and count. How many times do you see 0.000? I don't remember seeing any. And what confirmatory factor analysis does, it says, well, my prediction is 0. What I actually observed is a 0.01. That's a trivial error, but it's an error. And you're going to get penalized for that. But if you have another item that you're like, I bet it loads on this, and it does. Cross-loading is, according to my theory, 0. And you're looking at a 0.3, that's actually a medium-sized correlation for psychology. That hurts. That hurts. That's a medium-sized error in your model. For those of you who are working with the GBI, you're hopefully thinking, oh, sweet Jesus. There are tons of cross loadings. We've got a bunch of these that are 0.3s. We've got items that are doing 0.4 and 0.5, and we got big loadings on multiple things. And in this model, you could say ahead of time, I think that for theoretical reasons or based on prior data, I think this item is going to cross load, but you have to call it all ahead of time. Still with me? So the test of how bad are the mistakes in your theory, how bad are the mistakes in your prediction, is it's adding up all the errors. So what we'll see in the EQS output that I have marked up is, hey, here's your correlation matrix that you actually see in your data. Here is the correlation matrix that is implied by what you wrote down as your factor model. And here is the difference between the two. And so you get a whole matrix of errors. And some of the errors are going to be negative, some of the errors are going to be positive. So we square all the mistakes so the signs don't cancel out. And then here's the kicker for you guys. You take the mistakes and you weight them by sample size. So the same mistake counts worse if it's based on 1,000 people instead of 100 people. Imagine how much that's going to hurt when we have mistakes based on 13,000 people. Ouch. So we're going to this is I wish the professor had told me this before I signed up for the class, because I had to take 3 graduate classes to get to this lecture, and he is breaking it down for us like pretty much every model I've ever seen fails, and you're all doomed. And I'm like he wasn't wrong. So why we're learning this though is that this is a cool way of looking at, does the measure behave the same way across multiple groups? So when you guys have this skill on your toolkit in your toolkit on your belt, you're going to be able to look at questions like, is it the same number of factors for men and women? Is it the same number of factors when I'm describing myself versus my partner or my parent is describing my behavior? Is it the same symptoms that are associated with each factor? So this is going to put everything on the table. Everything's going to be up for testing. So that's one of the strengths of this. So one of the weaknesses is every model is going to be wrong. One of the strengths of it is it's going to give you a way of figuring out exactly where are things breaking, exactly where is stuff going sideways. And the idea of testing mistakes, testing errors in prediction, when we get to comparing groups to each other, what you're actually doing is saying, okay, I've got a model that I can live with. I've got a model that's providing acceptable fit. I'm going to test whether the same model fits for both groups. And that actually is making a lot of risky predictions. Is the loading of item 1 the same for men and women? That's one equality constraint. Can I use the same number, or is that a mistake? If the data say the correlation, the loading is actually higher in women, that's a mistake. And how different those are is going to be your penalty, weighted by your sample size. Do they have the same average item score? That's going to be another risky bet. And if they don't have exactly the same, it's technically a disturbance term or a structured mean. If they don't have exactly the same value, that's going to be a discrepancy, and that's another penalty, and that's going to be weighted by sample size. So So I wanted to show you a picture and then show you some output. The picture here, we've got a bunch of emotions, and we've got 2 factors. And the way that you draw pictures of your model is the things that we actually have data in the data set, the things that we actually observed the scores. Those are called measured variables, or observed variables, or manifest variables, depending on what book you're reading. But it's like, yeah, no, we got a score. This is what they got on that item. This is what they got on that scale for that emotion. So it doesn't have to be items. It could be scales. For the PHQ-9, it could be the 9 items, or it could be, I added them all up, that's the total, and that's what I'm going to put into the model. But everything that we observed gets a rectangle. So now I'm teaching you how to read these in papers. Anything with points on anything that's in a rectangle, they measured it directly. Anything that's in an oval, That's the factor. That's the latent variable is the technical name for it. So this model is saying I've got 12 emotions that I measured in the data set. This is real data. I could give you the data. So I've got 12 emotions that I measured. Scale actually had 36 items on it, 3 items per emotion. So this is adding up the 3 items for contempt, the 3 items for disgust. And this is saying I could summarize the correlations between all 12 of those emotions by boiling it down to 2 things: positive emotions and negative emotions. And 9 of the emotions go on negative emotions, and 3 of them go on positive emotions. P.S. Positive emotion and negative emotion not correlated with each other, totally independent constructs. If we were sure about that when we were doing an exploratory factor analysis, we would do Varimax rotation. We would force it to pull these out so that they're not correlated with each other. If we're not 100% sure that it actually is 0 to 17 decimal places, we could do an oblique rotation like Promax and let the data tell us these are actually slightly correlated. Or if it's a 0.3, that's kind of bad for the theory. If it's a 0.5 or a 0.7, that's really bad for the theory. The way that you figure out what the model is predicting for the correlation, right? We could look at the data, but and that's what you've already done. But in a confirmatory analysis, if we were playing this as a game, it's like write down your model ahead of time. I'm not letting you look at the data until you've written down your model and said exactly how many factors, which items are connected to which one. And we could take that set of equations, what you're writing in Lavaan is equations, and we could draw a picture. So the equation for this in Lavaan would be one factor is called positive affect, and it is a function of joy plus surprise plus interest. And factor 2 is negative affect, and we predict it looking at scores on all 9 of these items. The way that you figure out the predicted correlation is by multiplying all the arrows that connect the boxes. So the predicted correlation between anger and contempt is the loading of anger on negative affect, this arrow, multiplied by the loading of negative affect on contempt. So the way to get from anger to contempt on this map, on this diagram, is, well, they're connected by negative affect. So we go zing, zing, and the product, you're multiplying the two. The product of those two is the correlation between those two. Because according to this picture, the only way that they're correlated with each other is because they're both connected to negative affect. Anger to disgust is going from anger to negative affect and then up this leg to disgust. The part which is subtle, and if we wanted to spend a lot of time on it, we could actually like work an example. This is imposing constraints. If anger has a really strong loading with the negative affect, and so does self-directed hostility, the predicted correlation has to be something pretty big, because it's a big number times a big number. If they're actually not very correlated with each other, that's a mistake in the model. And if self-hostility wasn't very correlated with any of these, that would be summarized as a weak loading. It's like all these are pretty tightly connected, but this one is doing something different. But you can't have it both ways. You can't get very precise predictions of things that are different than average within the factor, or it's going to be misrepresented by the loading. That was really clear to me, and as I was listening to that last part of that sentence, I'm like, that sucked. That can't have been helpful. But let me say something let me show you a different thing that's going to be much clearer and more helpful. Here's the part which is spectacularly bold. According to this model, what's the predicted correlation between anger and joy?
0.
Right, because there's no way to get there. You can't get to joy from anger, according to this. These two don't have a correlation. That wipes out a huge number of correlations. That's saying, I don't need to look at the data. I can tell you ahead of time. All of those are 0. That's like 36 correlations that it's saying, no, sorry, 27 correlations. It's saying they're all 0. Really? Really? Okay. So let's look at some output to see how this works. So this is a program that you're probably never going to use, but it's a really good program. And this is the output. I bought, this is so good, I bought the program twice, and darn it, I used it, and I used it with these data. So we're gonna look at the output.
Eric, just so you know, time is technically up, but just finish.
Well, I said 25 minutes and we have 30 minutes. So this is my 5-minute warning. We're good. We're good. All right. So we've got the item. These are item names, not scale names. And we've got the means. We've got the skewness and the kurtosis and the standard deviation. You guys know what all of those things are. If you've had 525 with me, then you're even good with skewness and kurtosis. Other classes don't cover that as much. Multivariate kurtosis is next level kurtosis. It's a measure of, when we look at the combinations of the items, is the distribution jacked on the combination of items. And this one is a bottom line number, looking at all the correlations of all 32 items on the HCl. How jacked is that hyperspace distribution? The less jacked it is, the better it fits the assumptions of the model. So this is just checking assumptions. This is looking for outliers with extremely odd scores on the variables. Like, that's kind of a bizarre age, but we're not using age in this model. And then this is the residual matrix. So as we look at the predictions that the model made, this is a summary of all the screw ups. This is all the errors. As we go, and then this is a plot of how bad are the mistakes of the model. So it's giving us a huge amount of information, because the model actually is making a surprising number of predictions, and each risky prediction that you make is a degree of freedom. So you can get a sense of how gutsy is the model. Wimpy models, the wimpiest model doesn't make any predictions. It's like, I'm just going to describe the data. Okay. That costs 0 degrees of freedom. A baby step is like, I'm gonna make one prediction, and that has one degree of freedom. This model has 190 degrees of freedom. So it's got 190 places that it could be wrong. And it is not badly on all of them, but and then we take all those errors, we weight them by sample size, and that function is distributed as a chi-squared. So we get a chi-squared test like Grace lived with all semester, but Grace was rooting for hers to be significant. This is a test of, does the model make significant mistakes? So with 190 degrees of freedom, we get a chi-squared of 4,000. That is wickedly significant. So this model does not fit so great. The people realize these never work. So all of the additional fit statistics that we've got here are people, including Ken Bolin, Yes, Ken Bolin, that Ken Bolin, who is a professor here at Carolina in the quant program. He's written multiple books on this. So he's invented a bunch of these. And and McDonald was here for a while too. So they're like, yeah, we're aware of the chi-squared thing, not super duper helpful by itself, because if you've got a big sample, which you should have, you want a big sample, your model's always going to be wrong. So the rule of thumb that people say, so we got a whole bunch of these. In the output, I wrote notes about these are conceptually interesting. This is like an R squared that you get from a regression. That's pretty cool. But the one that is the most accurate, the ones that the field are usually reporting out of this set are the CFI or the Tucker-Lewis index. The CFI, the rule of thumb that a lot of reviewers use, is a 0.95 or higher. A 1 would be excellent. A 1 would be perfect. A couple of these can actually go higher than 1. They weren't supposed to. But like a 1 for a correlation, that's as good as it gets. So you can sort of remember 1.0 would be like perfect. If you see something higher than 1.0, brag. But and only a couple of them can do that. And then like the rule of thumb that people are using is a 0.95 or higher is good fit. Of the 4 to 8 models that you guys are likely to run in the next week or two, I'll be surprised if one of them has a CFI higher than 0.95. There are a bunch of other fit indices that we'll talk about later. When you actually have your model have the output, we'll look at the other one. So we're not, if we get a significant chi-squared, I'll be like, told you, don't worry about it. If the CFI is higher than 0.95, email me and I'll be like, wow. And if it's not, don't worry about it. We'll talk about other fit indices. The ESEM that Rachel emailed the HCL team about is a technique that was new to me that I've been talking with people about and trying to read since Tuesday night to learn more about. I think it's wicked cool because what it's going to do, the gist of what it's going to do is all the things that we're like, these are not major loadings. It's not going to force us to predict that the loading is 0. It's going to let us use a much more realistic number for the cross loadings. So the fit is not going to be anywhere near as craptacular as what they taught me to do 20 years ago. So, so this is the wrong program, wrong output, but this is a cool teaching example of we've got a model. You have a picture of what the diagram would look like. You have the idea of connecting the bubbles and squares on the diagram. That's where the prediction is coming from. And when there is no way to get from one variable to another variable, that the implication is these are correlated 0. There is no connection. I don't think any of you have worked with mediation, but it turns out that's also the guts of mediation tests. Is the strong claim for mediation would be the only way to get from treatment to outcome is through this middle variable. So that is implying that there is no other direct path. There's no way to get from very bold prediction. All right, so that's sort of your conceptual overview. When you look at the code that's coming, that Guillermo or Seifa may send other stuff around, what you'll see is all that we're doing is writing, here's how many factors, and these are the items that go on each factor. And then the output is going to give you, it's going to give you estimates of the loadings, and then it's going to give you a bunch of information about, and you'll see a chi-squared. It's going to be big. You'll see a CFI in the output, and I hope it's high, but I'm not holding my breath. and you'll get a ton of other output, and you'll be really curious about the other output when we talk next, because you'll be like, is this salvageable? Is this hopeless? It's going to be salvageable. And the details are going to give us a really good sense of where's the model going wrong in a much better way than we knew how to do last week. All right, so that was, I know that was over 5 minutes, but that was the best I could do on a first take.
We have built-in cushion time. It's okay.
If you guys have questions about this, put them. What would be the best place to put them? Do we already have a Google Doc going for this? Oh! If you guys have questions, the place to put them is on here. So this is a Google Doc now. Can edit. I want to make this comment. Copy link done. In the chat. So you guys could put questions on this, and the slides that we were looking at are not a Google Doc yet, but the water carriers have the privileges to make a Google Doc copy. And so you can send around the slides and people could put questions directly on them. That if the bike ride had been longer, that probably would have occurred to me on the bike ride, but I'm glad it occurred to me now. You guys could see the aha. All right, so I'm going to stop sharing so that I can pass it to John. John, do you have the super document with all the HCL team stuff?
I do.
Nice.
It is unfortunately a Word doc, not a Google Doc, because Google Docs kept crashing on me today, but we'll power through.
I didn't know that it could do that. That's
didn't either. It's been a really educational day.
All right. So you want to orient people to what we're looking at?
Sure. So on this document, I collected everyone from HCL who submitted a draft for the methods section. So you're going to see a number of things repeated. There's going to be some discussion about how data was collected, how data was cleaned, what the HCL is, and maybe some discussion about some of the demographics that were reported in the data. There's also at the back end going to be a rough draft of the table. And then you asked me to drop Chase's code into the bottom of it too, so we can talk about that.
Nice. All right, so we've got 5 pages of stuff.
Yep.
So the idea here, what we're trying to do in teaching mode is have everybody have a chance to do a draft of each part of the paper. This is not being graded, and so there's no penalty if you don't do it, but there's also no learning if you don't do it. Well, a little bit if you're paying attention now. So we have redundant. One way of looking at it is we've got redundant things, but from a learning perspective, we don't. Everybody who wrote stuff had to think about it, and you guys were learning as you were putting it together. Second thing that we're doing is putting them all next to each other and comparing them. That's another learning moment, is you're like, oh, that's a different way of doing the same, solving the same problem that I was trying to solve. Third way that it's learning is deciding for us as a team, what do we think is the greatest hits? What is the best way for us to accomplish this particular objective and pass it forward to the next round? So and what we've talked about, so this is the first time that I've tried doing this with the ARF at the same time. So if we I don't have an ARF pulled up, but imagine that we did. Imagine that we were looking at the ARF for the HCL project, and there would be a method section, and then there would be a describe the measure, describe the sample, and there would be points for each of those. So one way of thinking about what are we doing with round 2 is we're actually writing a draft of the paper, and on the ARF somebody would get points for doing the measure section. When a small team is writing the paper, usually they delegate that to someone. So they'd be like, Chase, you write the measure blurb, and Wilson's not on this team, you write the participants blurb. But here, all of you guys are writing all of them if you choose to play along. So what we could do is color code each section. So Rachel could be in light green, and John could be in light yellow, and light so that it's not, so it doesn't look like Attack of My Little Pony, and light so that it's easier to read the text on the background. And then as you copy and paste stuff over to the super document, then you have a color map of like whose stuff are we moving over, and awarding points towards the ARF for that. The other thing that I'm suggesting that we try out is keep track of who participated. So on no ARF before July of 2021 have I ever given participation points, but now I think we should. So everybody who sent a draft to the section, I'm like, woohoo, you got a participation point for trying this. Even if we don't use any of your material in the final version, that's okay. We want to give you credit for playing along and actually actively participating, and you're still learning, and you're contributing. You were part of the discussion. Participation points I've never done before, but the idea of giving points for learning, I have. If you look at every ARF that I've ever done, there always is a statistics wingman. Every project that I've done, there is who's leading the statistics, who is checking the statistics. So this is not like totally uncharted territory for me. This is just expanding that idea to the rest of the paper, and the not buddies. This is team participation. So okay, so Rachel's this is a Word document, so I can't touch it. But we could color code this, but let's just scroll through in the interest of time. So we've got participants, we've got procedure, we've got the N, we've got a description of the measure, we've got the anchor publication. We've got outline for the statistical analyses. So this wouldn't be what we would put in a paper to send to a journal, but this is fantastic for right now. So this is, and then a list of the psych packages. So I bet things that look unusually detailed to me are specifying all of the packages. That's really, really cool. And go back up to the top. There we go. So this is unusual. She says, I got 16,607 participants, but I actually only used 11,589. And if you rewind the tape, she was the one who was asking, is it okay if we clean the data? Is it okay if we only use a subset of it? And I said, yes, that is actually definitely what we want to do, but we want to have some discussion and documentation about how we do it. so she's doing exactly what I want us to do. This is beautiful. Technically the full sample gets a capital N and italicized, teeny tiny thing. The other, I'm not going to go down this rabbit hole, but I have a lot of thoughts about the reporting the full N and then what we actually use. All that you guys need to take away from this tonight is I'm proud of you. We're probably going to want to change the way that we do it in the paper, because every time that I've tried to do this, being very upfront about the process, the reviewers kick me about it, and I'm like, but I'm being transparent, and they're like, why'd you throw out 5,000 people? That's kind of a lot. That's like a third of the people that you could have had, and so this is I'm doing the rabbit hole, but this is what I call a kick me here thing, where me trying to follow best practices for reproducibility and transparency and me trying to do it the right way and telling people doesn't get me an attaboy, high five. I'm so impressed with the detail and clarity with which you reported this. They are like, we're deeply concerned about potential bias, and they reject the paper. I'm like, you're kidding. I know you do it too. You just don't tell. You lie. You hide it. So there's going to be an art. There's going to be an art and to this, because I'm not going to be like, just lie. Everyone else does. No. But there'll be some revision around how do we actually describe this so that we get bonus points, not a kick me here. But this is excellent. Next, down to page 2. So we've got a description of the measure, super clear about the scoring, which is a really nice detail that a lot of people omit. Where'd you get the 4?
Yeah, I was kind of unsure about that, but then I looked it up and that's what it said. I was like, not sure if that was right. So I was going to kind of ask about that in our thing tonight.
Interesting. If you could drop a link where you found the 4, I'm curious as heck about it, because 32 times 0 would be 0.
Yeah, that's what I thought it was at first. And I was like, and then it got, I don't know if it's because like the questions that, the website that I was on included like the questions that are in like the yes or no section. I don't know.
Yeah, excellent. Cool. All right. So obviously shorter, but for those of you who don't know, Lillian is still in high school and Rachel is finishing her super sophisticated master's. So this is a big contrast in terms of background coming into this. So excellent. Grace has good description. And I like saying exactly where the data are coming from. So housed on the dbsa.org site. If we send this to in the version under review, because that would disclose the identity or break the blind. And same with the North Carolina, but for right now, those details belong. And in the final product, if it survives peer review, they would get added back in. We have the time frame that the data were collected, which you got from the dates completed in the Qualtrics. Some journals actually include that on a checklist of things that they want to see in the paper. And so this is the first time we've seen that detail. Psychology journals usually don't ask for that, but psychiatry journals and medical journals often do, and we don't know where we're sending this yet. So that's a really good addition. And Grace's is going with the bottom line after we did the NA omit and after we got rid of, did some limiting it to the people that had complete data on the things that we wanted to look at. This is what we got. Excellent. Next. We've got the anchor pub. We've got, ooh, that's a nice detail. Not all items load onto one of the two subfactors. I believe, I'm not reading every word, but I believe that's the first time we've seen that. That's a keeper. Especially as you're thinking about it with when we advance to the confirmatory factor analysis, that's a really interesting question. What do we do with those? Do the data, angst data, already say these didn't load anywhere? Do we ignore that and put them on one anyway? Do we put them all on Pluto? Do we not include them in the model? If you include them but don't attach them anywhere, every loading, every correlation is an error. So that's I hadn't really totally thought that detail through until right now. That's a really cool electronic self-report. Yep. Oh, and this is super detailed about the participants. So we've got the demographic breakdown. We've got, oh, this is really nice. Granular. All right, let's see the table.
So I didn't get too far with it because I didn't really know what these corresponded to at a certain point. I do need to add the Pluto factor at some point.
Yeah. Okay, this is excellent. So so this is exactly what I was hoping people would do. Take the table from the manuscript that I sent around and then customize it for your particular project. So we've got the full length, we've got dark and sunny. Manual means coming from the Zurich scoring manual, not the, yep. These John knew where to pull out from the output. Fan freaking tastic. And these John was like, I don't know where they came from. I haven't taught you yet. But these two, so the savings length, the savings would be a simple percentage, but that would be if you only gave Sunny and threw out the rest of the items, then that would be a 50% savings in number of items because that's 16 instead of 32. So that's how you're calculating that. These are all fancy formulas that I don't think are in R. They might be because Ravel, the guy that makes Psych, is throwing tons of stuff in, more than I know about. But the way that I calculated all of them is in Excel or now a Google Sheet. And I pulled the formulas in from a paper by Smith called The Sins of Short Form Development, published in Psychological Assessment. And so all of these, when you guys, especially Team GBI, if you were making a short form or using one of the short forms, then you would want to calculate all of these. The standard error of the measure is actually very easy. This one is a function of the standard deviation and alpha. And standard error, the difference is this number times the square root of 2. And these numbers are just confidence intervals. So this I could teach you guys how to do in 5 minutes. this is fancy, and don't try it at home. Just have me show you the cheat sheet. Cool. This is excellent.
And then we come to Chase.
Last but not least. And
All the
this
stuff
is,
I have highlighted is stuff that I was like, this might be a good thing to add, but I don't have the information yet and want
Yeah.
to. So
yeah. No, this is, I love, so what this illustrates is exactly how I write, and really encourage you guys to as well. So a bad way to approach writing is to type, to do it in a linear way. So imagine Chase chugging along, and then she gets here and she's like, I don't know the answer to this. And then she stops writing and she goes down a rabbit hole to answer this question. So that's it for writing for that day, for that session. And then she comes back and she writes until she gets here. And she's like, I don't know the end. And she stops, and that's a second day of writing ended because I need an end. And then she sits down and she types 2 letters on day 3, M equals, and she's like, oh, snap. Now I need to go open up SPSS, open up R, pull down the data, get a mean, and then she types in that one number. And then day 4, she's like, standard deviation. And she's like, I can't believe I didn't get that when I was looking at the mean. And she stops writing and pulls down R and runs and gets the standard deviation. And then she types females, and then it's like, oh no. Day 5, here's the N for the number of females. And then day 6 is the mean for female. And the and it starts to really get exciting. Will Chase ever graduate? Will she ever finish her thesis? Will she?
I've definitely written like that before, and then I realized I should just make comments and leave little notes for myself to do it later.
Yep. And so this is and then next level stuff that Chase is doing is highlighting it. I use highlighting for other things. So my MO is to put a bunch of asterisks, and then when I need to find the loose ends, I do a search for a bunch of asterisks or y, or a bunch of X's. But something that's easy to type. All of my tags are just hold down a key and let it repeat itself. And something that won't show up for other reasons in the paper, and then just look for them. Same thing with references.
That's genius.
same
I'm definitely doing that.
Same thing with references. And we've already seen this with some of the other ones where people are like, I know there's a reference, I'm not going to break my flow to find the reference, but you put enough to remind yourself, this is not a real reference yet, and this is where I'm looking for it. And that's great. Last thing before we go to breakout rooms is you guys, when you guys work on projects long term, you're gonna find that you have good days, and you probably not a whole bunch of days where you're like, you know what I want to do today is spend hours working with R or hours writing the results section. In my career, I've had very few days like that. You got to make yourself show up. But then when you actually start working, there's some days that you're like, I've got my A game. I'm on, and there are other days that you're like, I'm tired, I'm stressed, I'm undercaffeinated. You have your B game. When you have your B game and you're trying to write and it's not flowing, that's the time to go and fill in the ends and the means and the standard deviations, or pull up your Zotero and plug in the references. It's got to happen sometime. And the days that you're like, it's not working for me, do the easy stuff, pick off the buff and polish. Other thing that fits in that same category is rereading, editing, but like just rereading. And when I reread stuff, I can't help myself. I make little edits, but it's easier to trick myself into doing that than it is time to edit your own work. I don't want to do that, but just reread it. And what I tell myself is rereading it is like, well, I don't actually feel like writing, but I can at least make myself read the stuff. That's much less energy. And that still is getting your brain to think about it. And any tweaks that you make, it's getting better. And those didn't have the same friction or resistance to get yourself to do it. All right, so your code, you said you're getting an N of 1. Yeah, I see the problem. It's the race variables.
I had a suspicion that it might be.
Yeah. Grace, are you still in the house?
Yes, I'm here, sorry.
Sweet. You used a different race variable. It was either you or someone else that I worked with to solve this problem with the HCL data. Is this ringing a bell?
I didn't consider race in my analyses, so it wasn't me.
It may have been Sally. So here's
Emma worked with Hispanic race in her analyses.
Yep. So here's the problem. The way that Qualtrics tracked these variables is either a 1 or missing. There is no 0.
Why?
I don't know. But this is my nemesis. This is with the Korea teaching data, there were the really cool variables that people were excited to play with, and I'm 2 weeks away from talking about creativity, and one of the creativity measures is entirely jacked this way. So what is happening is race 1. I don't remember the categories, but race 1 Asian and Pacific Islander? Is it alphabetical order?
Race 1 is white, 2 is African or black.
Yep.
And I don't remember the other. I think 3 is native, 4 it might be Asian Pacific Islander.
Yep.
I think that's his other.
So race 1 is 1s for everyone who picked white and missing for everyone else. And race 2 is 1 for the people who picked black and missing for everyone else. So Chase said, I wind up with 1 person when I list-wise select on all this. That 1 person must have checked every type of race. That is the only way to survive this gauntlet. So that's fascinating. It's easy in R to write a little piece of code to be like, actually, I want you to make a new variable, which is so we could have a variable white dummy, which is a 1 if race 1 is a 1, otherwise is a 0. That's easy. The problem with that is you guys in this data frame have some people that just didn't answer any of the questions, and they're going to get assigned a race even though they didn't answer a race, right? If we're like, for this one, if you said yes, you're a 1, otherwise you're a 0, all the people who just folded their arms and are like, I'm not answering any of these, we're accidentally going to pick a race for them if we do the obvious fix. For me with the Korea data, I'm like, if I do the obvious thing, then I'm going to assign a whole bunch of people a score of 0 for how creative they are. So I don't have a perfect solution for this, but my middle way that I worked through with Sally Haddad was look at other variables, and if the other variables are missing, then treat all of the race variables as missing, all of the gender variables as missing. So like, so going back to Rachel's point, if we have other reasons not to trust this row of data, don't make up legitimate values that probably aren't accurate either, and include them in the analysis as if they were legit. If we have other reasons to do you guys use the term yeet? My daughters are going through a phase where everything's getting yeeted. If we have other reasons to yeet that row, then then let's write our code so that we don't accidentally fool ourselves into using them in an analysis when really they should have been yeeted. So the fancier part of the code that we want is the yeet yes no. We eating you. If we're not eating you, then we'll go ahead and fix the race variables. Cool. All right. Now I know we're way off time, but to the breakout rooms.
Breakout
Eric,
rooms
you
should
coming
be
with
open.
us? I said, are you coming with GBI?
Great. Hi, everyone. Welcome back. Eric, are there any specific goals that we should have in mind for next Thursday? Also for the other water carries, if you have any ideas of what would be like a realistic goal. I believe you're muted, Eric.
Did the groups already report out?
Not yet.
Let's do the super quick report out from each of the groups, and then set the goals.
Yep, sounds good.
Nice.
I'll start with Scare. Scare team basically just got itself reoriented, make sure that we knew what we had to get done to catch up to where all the other groups are, and we're hoping to accomplish those goals and whatever goals are for next week. So
And I've told Dr. Perez Algorta that you guys might want to reach out. Is this a week that you would want to activate that lifeline, or do you want to?
I'd say next week would be more
Cool.
ideal.
Sounds great.
Mhm.
Cool. And popcorn over to another group.
Popcorn, Cypher, because you seemed ready.
So the PHQ9 group just sort of reoriented. We talked about getting things written up. However, most of my members are really busy for the next week. And so we decided that we could take a week off, and then the following week we'll be assigning more things to do. And we went over a lot of the output and the data that we have and discussed future directions of the paper.
Nice. So the whole PHQ9 group is sort of slow rolling this coming week.
Yep.
Got it. All right, that's helpful for what should we be doing in the coming week?
Yeah. Are you asking me specifically, or?
No, sorry, I accidentally up-talked at the end of that. Who are you popcorning to? GBI or HCL?
GBI.
Well, we're still a little unclear on all of our updates, but it seems like we're going to be working on looking at a paper either with like dialers, so to help clinicians make assessments on how severe a score is or is not, depending on their population, and or comparing which informant clinicians should potentially use within age ranges, or when it would be helpful to use either a self-report or parent report or both. So we're still kind of trying to figure that out, but that is what we discussed.
Do you have a copy of the paper that I was looking at with you guys?
Yep.
The last tables in that paper touch on exactly what we talked about at the end of the didactic chunk, do the factors predict different things, is what sort of, that's where the rubber hits the road. The last two tables in that paper have examples of comparing different scales and looking at, do they correlate differently with stuff that matters, like diagnoses or gender or age or a bunch of other things. The why that could be interesting for you guys to look at is to sort of see, here's a finished product that has that as a capstone rather than ignoring it. The code that I used to run those analyses, there's an easier way to do it in R that I didn't know at the time. So that's actually, I was ridiculously proud of those tables, and it'll be much easier. You'll be like a piece of cake, sort of. It's a souffle. It's a little bit more work to get to do the right thing. But for the PHQ-9 and the HCL and the other groups, the part that I don't know yet and would like you guys to start thinking about is, are there other things in this data set that would be interesting to predict in their own right? Do we have criterion variables? Grace's poster is a great place to look for the HCL stuff, because she looked at a bunch of the impairment and functioning questions there. The PHQ-9 has a suicide item that a lot of other people would pull the suicidal ideation off and use that as the criterion, but then you're doing the PHQ-8. So that would be cool. So that should be a thing. What should the groups be thinking about this week? Think about what would be, when you have your factors in a form that you are happy with, how would you take them out for a spin? What would you want to see? Do they make different predictions about, and what's the coolest thing that you have in the data to be like, now if these don't make the same predictions about that, that's cool. That would impress Eric, that would impress a clinician, that would impress somebody going to the website to be like, do I need help? And so I don't have the answer, but I'm like, that's a really cool question that just emerged. All right, so Kelsey, if you could jot down what we were saying when the breakout rooms dissolved and brought us back to Kansas, I'll be able to elaborate. And Colin, you did absolutely the right thing. So last group is the HCL.
Yep. We talked a bit about data cleaning, and we came up with some internal deadlines to come up with a data cleaning proposal in code, and also to take a first run at selecting what we liked about each other's method sections and putting together maybe a potential collective knit.
Fantastic. So thinking about the Colin's question, what should we be working on in the coming week? Three thoughts about this. One is several groups or people are like, next week is an off week. So the PHQ-9 group already said that. Lillian and Dwani, this is their week break in the middle of their internship. So soft week for them is great. I would love personally to do less next week because I'm going to be in Seattle and Oregon, and I'm going to be trying to hike in some national parks during the day, but not miss important HGAPS meetings. I want to slow you guys down. So I'm going to be at the Thursday thing for sure, but the other ones I'm like is there anybody else that wants to slow roll next week? Oh, Kelsey's defending her masters. And it's like a performance, and yeah.
The first half. I have another half in November, but yes.
I'm gonna give the scared team time to catch up. All right, so I'm gonna make my goals for the week relatively, or my suggested goals relatively modest. So team scared, take advantage of your reorganization and having some, yeah, that sounds beautiful. Everybody think about when we have our factors ready to go and we really feel pretty good about what goes on what factor. How do we take them out for a spin? What would be a criterion that we have available? For the groups like the PHQ-9 and the Scared and the HCL, there's good stuff in there, not the best stuff, but there's good stuff. And so thinking about that would be great. When we're done with that, then remember other people have used these measures. There are other data sets that have them. And I know the authors. I can't guarantee that they will share, but I can ask, and they'll at least respond to the email. So cool. Other stuff that you guys think would be good. I'll send you guys the code for Levon. Anything else that would be good to work on? In the big picture of we wanted to try to get 8 papers done by the end of the summer. The GBI paper going to that one still is our lead for the manuals in the cloud. The table that John showed for the HCL actually is a draft for the manual in the cloud for the HCL. So you guys are making headway on that. And Team Scared's like, okay, now that we have the exact model, we can do that. Wilson already wrote a bunch of the code for looking at the subscales, and so we'll continue to move the pieces into place. If at next week, water carriers and SAFA and people that have more our experience, what would be awesome would be if we could get at least one model run in Levon with output to compare to the EQS example that I sent around. We could we could use the PANAS data that is up in the drive. You guys haven't seen that data before, you haven't thought about that data before, but I already have it worked up in EQS and SPSS, so we have like a key. So that could be one possibility, or we could continue whichever group gets there first. That's what we'll look at. Either of those is cool with me, and that seems like plenty for this week. And Kelsey, tell me the implications of what you were saying at the end. Are you the magic Zotero fixer?
Yes.
So do I need to add you to any other things that need fixing?
If you add me to the 525 one, then I can move the 525 one over to the HGAPS one.
So clutch. Am I adding your Gmail account?
Let me check what my Zotero username is.
Uh-huh. So I'm positive that we will be packed and out the door roughly around 4 a.m. and on the plane. I'm not sweating that at all. I've done this so many times. The thing for you guys, if you want like a betting interest or a pool, in the chat, put in a number for how many things do I forget, given that this is a late night rush job. From 0, Eric, before COVID, Eric traveled so much. This is a well-oiled machine. He could do this in his sleep to I don't know, a big number. So every time I face palm, every time I'm like, oh man, I'll do a chicken scratch. I'm feeling 3. But one important thing for unimportant. Oh, that's a very precise prediction.
I mean, like there's things like, oh, I forgot to bring this specific pair of socks, but I have others with me, so I'll be fine. Yeah. But like one important thing, like laptop cord, don't forget that, you know?
No, I for the stuff like that, I've gotten so burned that I usually pack 2. So I'm gonna have like 2 power chargers and at least one other way that I can get to Dropbox. And
good.
I had one nightmare scenario where I brought the damn thing and it fried when I plugged it in, and I was doing a keynote or present, it's like something really big. I'm like, does anybody have another? And nobody had the same brand of laptop. So I it's the only time that I paid for express shipping on Amazon.
Oh no.
And then the hotel. So it was the hotel. So they charged $30 for handing me the thing. They're like, yeah, no, there's a receiving fee. I'm like, okay. I'm not gonna say no. That was San Francisco. Not that I'm bitter. Not that I remember the exact thing. But because you guys are playing along and there are numbers in the chat, and Chase offered a super nuanced and precise thing, if that happens again and I pack it and it blows up, that does not count in this contest as a me forgetting it. That's just bad luck.
Are you gonna tell us what you forget?
If it's not too personal, yes, I will.
Okay. Don't forget to let us know how close we were.
No, yeah, no, you played. I will be accountable.
I'm invested now.
I will report it. Yeah, no, this was a really interesting coda. I'll try to pack well. And I'm trying to think what would be embarrassing. I'll tell you what I forget. I'm obviously a man who has very few secrets. All right, peeps. Anything else helpful?
Yeah.
I never got the break to go get the. I'll send you a picture of the card. All right. Have an awesome night. Great week. I will see you Thursday, if not sooner. Welcome to the party, Leah.